Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout hosted by Kausar Kamal. We are also excited to have Kelly Hare, a solutions architect at GitLab, join us for this hangout. Today, we're going to talk about HashiCorp Terraform Cloud and Vault. HashiCorp Terraform uses infrastructure as code in order to provision any cloud, infrastructure, and service, and Vault manages secrets and sensitive data. Kausar and Kelly are going to discuss how to use GitLab CI/CD pipelines and runners to interact with Terraform Cloud. You'll learn how to implement Sentinel policy as code as part of infrastructure provisioning workflow and use HashiCorp Vault to retrieve cloud credentials. I also want to note that the Hangout is recorded and the recording will be made available after post-processing, usually within a day or two. I'll email it out to all of you. The demo will be about 20 minutes and then we'll allow up to 30 minutes afterwards for questions. So please submit your questions throughout the demo through the GoToWebinar portal, and then we'll answer them at the end. So with that, let's go ahead and get started. Take it away, Kausar and Kelly.
All right, sounds good. So just one more check, make sure you guys can see my screen. Okay. Hello, everyone. So my name is Kausar Kamal. As Brianna said, I'm a senior solutions engineer supporting the New York Metro region with HashiCorp, and there are some of my contact information. Okay. So as we go through this journey from traditional sort of on-prem infrastructure to more dynamic multi-cloud infrastructure, right, we have this complexity of having to deal with a variety of different platforms, right? So Terraform open source solves the challenge of coming up with a consistent workflow that works across, that solves the challenge of infrastructure provisioning with a consistent workflow across a variety of different sort of infrastructure provider, whether that's private cloud, such as on-prem VMware, or any of the other public cloud providers. Now, as you scale your infrastructure as code practice with Terraform beyond a single user, so you go to, as a team using Terraform open source and then sort of multiple teams and entire organization using infrastructure as code, you're going to start to run into some challenges around sort of collaboration and governance, right? And that's really where Terraform Cloud comes in. So Terraform Cloud is a enterprise server that's managed by HashiCorp. So that's our software as a service solution. And it provides a workflow around the Terraform open source binary that you might already be familiar with. We also have an on-prem version called Terraform Enterprise. Previously, it used to be called Private Terraform Enterprise, but now it's just called Terraform Enterprise. So we do have a self-hosted model as well if you want to do that. Some of the use cases that Terraform Cloud and Enterprise solves for is just kind of scaling your infrastructure as code practice beyond an individual. So things like allowing teams to have self-service provisioning through a private module registry, providing role-based access control and isolating individual units of infrastructure. All of that's provided through Terraform Cloud or Terraform Enterprise. And then we also have sort of this Sentinel policy as code, which we'll see in the demo today, where you can apply governance checks. Okay, so I'll hand it over to Kelly to talk a little bit about GitLab.
I just realized I was muted, so that's because I was crunching ice a little bit earlier. So thanks, Kausar. As Brianna and Kausar mentioned, I'm Kelly. I'm a solutions architect here at GitLab supporting the Eastern US, and the details were there too. Just like there we go. Thank you. And then so next slide, please. So at GitLab, we're on a mission to build a single application where everybody can contribute, and it doesn't matter if you're on the dev side or the ops side. We consider both devs and ops to be first-class citizens. Next slide. So there's a lot of words on this slide, but what I wanted to show is that basically our goal is to simplify and accelerate the time from when you have an idea or you come up with an idea to the planning and collaboration around the idea to the development and testing of that new functionality to realize the idea live in production. For the purposes of this webinar, we're going to focus really on the code repository, and then building and testing the code is typically what we see a lot of customer use cases around infrastructure as code. Kausar's demo will show how Terraform Cloud is used to deploy the code itself. So the context of this collaboration of how we're working together here is I ran into Kausar at HashiCorp in Seattle this year, and we discovered that we're working in similar veins for both Terraform and with both Terraform and GitLab for infrastructure as code. So from the GitLab side, what we're seeing is that customers are not only using GitLab for the SDLC or software development lifecycle itself, but they're also implementing infrastructure as code into their environment, and Terraform has really become the de facto standard there. Boxes you see on your screen there, those are some of the examples of different places that we integrate today. It's not GitLab is a single application that can support the whole DevOps process. However, we realize that obviously it's not green fields. I mean, there's going to be a lot of different tools in there, and then there's also tools that may be specific to a job at hand. So, like for example, a Terraform is an awesome tool for infrastructure as code for the whole life cycle of that infrastructure itself. With respect to this, Kausar is going to basically again go through the Terraform Cloud. I've also built a project that's up on GitLab for deploying to AWS using Terraform open source, and the project that's up there is really pretty much with GitLab open core. So that's in the resource list in this presentation. So actually, with that, let me go and give the mic back over to Kausar. Kausar?
Awesome, thank you, Kelly, for going through that. And yeah, we are going to post all of the resources, as Brianna said at the beginning. So when you interact with Terraform Cloud or a private Terraform Enterprise server, you create what's called runs, right? And if you're familiar with the Terraform open source plan and apply concept, the plan and applies are captured within the context of a run, and then runs are sort of sequentially put into a queue as if you're doing concurrent runs within Terraform Cloud. Between the plan and apply stages, we can also apply Sentinel policy as code, where you can apply governance or cost control checks there. Now, to create these runs within Terraform Cloud or Terraform Enterprise, there are a few ways of doing so. And one of the ways, as Kelly mentioned, is using something called a remote backend, and you can find out more details about that in Kelly's blog post. Essentially, what the remote backend entails is that you have this. This is an example of the remote backend, right? So you have a set of Terraform files here. I'm actually zoom in a little bit, just so it's easier for people to read. So I have a set of Terraform files in this repository. It creates some network infrastructure in AWS, VPCs and subnets and so on. And I have this backend.tf file, right? So if I look at the backend.tf, you'll notice that it has backend remote. A lot of you guys might be using S3, which is a very familiar, one of the most common backends that people use. With the remote backend, you can point it at the SaaS server, which is an app.terraform.io, or if you're running a private server, you can point at that host name. And then you can give it a Terraform Cloud organization and a workspace name. You can also do a workspace prefix. So if I do a Terraform plan at this point, or I'll do a Terraform apply, what ends up happening is instead of running this plan or apply in my laptop or on a build server, it's actually going to run this in Terraform Cloud or Terraform Enterprise and then stream the output back into my terminal. So if I switch to the Terraform Cloud GUI, this is my organization. It has a set of workspaces. You'll see that I've actually kind of triggered a plan and applied there. So the run was created using the remote backend. And I believe Kelly's blog post kind of goes over how to use a backend, right, to do kind of runs with Terraform open source. However, I think Kelly uses the S3 backend as well. So this is one way of interacting with Terraform Cloud. Another way, you'll notice all of these workspaces that are managing independent Unix of infrastructure. Some of them are linked directly to a repository. So I have already linked GitHub and GitLab repository with Terraform Cloud. And what that allows me to do is when I trigger a plan or apply in one of these workspaces, it'll pull the Terraform code directly from the linked repository. So that's called a VCS-driven workflow, right? VCS for version control. So if I kind of go into this workspace, I do a sort of a plan right from the UI. It's going to pull the code from my repository, and it's going to run a plan. And then if I want to, it will run an apply as well. So far we have seen kind of the CLI-driven workflow, which was the remote backend that I showed. There's also the VCS-driven workflow, which I had just triggered. This demo and this webinar is really focused on the API-driven workflow. So in the API-driven workflow, we have our CI system send a series of REST API calls to Terraform Cloud or your Terraform Enterprise server. And that's how we kind of deal with provisioning infrastructure, right, using this workflow. One of the advantages of this workflow in the middle is that you do not need to worry about having the Terraform binary in your CI system. So, a lot of guys and girls out there use different versions of Terraform. So, there's Terraform 0.12 or 0.11, and then even within those, there are different minor versions. And then sometimes it's a challenge to keep track of the different versions of Terraform binaries that you need to bake into your sort of CI system. The API-driven workflow is a more lightweight way to kind of interact with Terraform Cloud, where you don't really need the binary. You just send the rest of a series of API calls using curl, Python, or however you want to orchestrate that. And that's really what we're going to see in the demo today. So going back to my slides real quick, we're going to provision a server on GCP, which is going to have an application on it. The Terraform code is going to be stored in GitLab, which is our version control. So that's sort of the single source of truth. And then when we check in that code into GitLab, that's going to trigger a GitLab pipeline, right? So that's the GitLab CI/CD component, where a runner is going to pick up that job and then send the REST API calls to Terraform Cloud, which will then do the actual infrastructure provisioning within a workspace. And then in that process, it's also going to pull temporary credentials from Vault. So these are GCP service account credentials. And then the state files that are generated are also going to be stored in Terraform Cloud. So let's begin doing that. I'm going to go into Visual Studio Code. This repository is GitLab CI Terraform Cloud demo. That's going to be posted as well. So everything that you need to kind of do to reproduce this demo on your own is posted there and there's a corresponding blog post as well that gives you all of the different detailed steps that you need to do this, right? The root of the repository has this GitLab CI.yaml file, which describes the different stages in my pipeline. So in this case, I have a couple of different stages here. The get credentials stage will retrieve temporary credentials from Vault. And we're actually preceding this CI system with a Vault token. And I'll talk about how you can alternatively use a Vault authentication method as well to interact with Vault and retrieve Google credentials. We're going to create a workspace in Terraform Cloud. Now, this may have been created for you already, or if it doesn't exist, it will create a new one. It'll get a workspace ID, so it'll print out what that workspace ID is. We're going to need to set up a series of variables within the workspace. So as you can see, I'm setting up sort of, these are Terraform variables and environment variables. I'm setting up GCP region, GCP project, machine type. I'm also setting confirm destroy, which is an environment variable. And if we are not able to sort of get credentials from Vault, then you have the option of putting in your own Google credentials as well. So this might be good for testing. So if you just if you don't have a Vault server up and running, then you can put in your Google credentials into GitLab CI, and it will set that variable and use those credentials instead. And then we have this stage called config version. Actually, this is a job. The stage is under setup workspace. So the config version job will make a zip file or a tar file rather with all of your Terraform code and any other files you want. And then it'll create a configuration version in Terraform Cloud, and then it'll upload that tar file into Terraform Cloud. And all of these interactions are done with curl. So as you've noticed, now I have a series of curl calls, which are the REST API calls that I was talking about. And then finally, we're going to go ahead and start the run, right? So that's the plan and the apply phase. Okay, so let's start seeing this in action. There are a few different ways to trigger the run within GitLab or trigger the GitLab pipeline. One way is just to check in some code, right? So to do a commit, and whenever you do any kind of commits, it'll trigger the pipeline. You can also use it from the, you can also do it from the UI. There's a run pipeline button, or you can use it, you can do it by the API as well, the GitLab API. So let's go ahead and kind of check in these changes. Okay, so git commit, update a README. Okay. Then we're going to do a push to the master branch. And the pipeline sort of language is very flexible. All of this is really well documented. It's one of the reasons I really like GitLab CI is that the documentation is amazing. So you can say things like, only when there's a commit that's pushed into a certain branch, should you, run this job or this, or run the entire pipeline. But in this case, we're just using master for simplicity. Now let's go ahead and get into the GitLab UI. So if you go into CI/CD pipelines, as you can see, it has started the pipeline already. It says updated README, which is the commit message that I had just put in. If I click on the pipeline itself, you'll see that all of these stages, and the stages ran really fast, but we have all of the stages that we just looked at in the GitLab CI YAML file, right? So it's already done all of this, and it's actually already triggered and applied in Terraform Cloud as well. So all of this, happens quite fast. If I kind of click on any of these individual stages, I'll get to see the outputs, right, from the actual runners, right? So in this case, all of those curl statements that you saw, the echo statements and the export statements, all of those were executing and being outputted here. I actually have the runners on GKE. Another reason GitLab CI is really flexible is because you can have runners for your project run anywhere, right? They could be in Kubernetes, they could run on your laptop or any kind of server environment that you have. You can register a runner. So I have these two runners that are running as pods in my sort of GKE server. So as you can see, these are the two runners. I have a kubectl get pods running. The apply happened so fast. Actually, the pipeline ran through so fast that we didn't get to see the ephemeral containers it spun up. But when it goes through and runs the pipeline, there are actually other containers that are spinning up with the image that you mentioned in your GitLab CI YAML file. Okay, so now let's go back to the Terraform Enterprise UI and kind of see what happened there. Let's see. That was part of this. So going back to my workspaces view, my GitLab CI pipeline. So this is the run we just queued. And you'll see that it queued a pipeline. Let's see, so it finished the plan and then the apply is pending. So I can go ahead and sort of click confirm and apply, and it'll actually go ahead and kind of create this server within Terraform Cloud. So I'm going to actually discard that because I wanted to show the Sentinel workflow. Okay, so I'm going to just click on run. So now with the Sentinel workflow, one thing to be aware of is that you do have to upgrade your Terraform Cloud subscription to have the governance module, because otherwise, right, the free version of Terraform Cloud does not include Sentinel. So that's the only kind of FYI. All of the rest of this demo can be done, pretty much for free. So you can sign up for a free Terraform Cloud account, and you can do all of the rest of the items. So the Sentinel part is optional, right? You don't need that to run the entire demo, but you can if you want to. We have some scripts that I've included in this repository. There's one called Sentinel Setup. So if I do Sentinel Setup, what it'll do is basically create a Sentinel policy, create a policy set, and upload that to Terraform Cloud. So now I can go into settings. I can go into policy sets, and this is the policy set that was just uploaded, right? Last updated a few seconds ago. If I click on that, I'll notice that it's mapped to this workspace that we just created from the pipeline. If you want to, you can also upload or you can also directly get policies from GitLab or any other repository that you have. So that's an option as well. The other important thing from a Sentinel perspective is the sentinel.hcl file, which is also part of this repository, where you specify an enforcement level. So a soft mandatory essentially means that if there is a policy violation, then someone with the appropriate authority can go ahead and approve that change and still allow the apply to go through. Right, so if we now run this pipeline one more time, so going back into pipelines, yeah. Now, as I mentioned, you can also run the pipeline from the UI itself. So if I click on run pipeline, it will trigger the pipeline again. You'll see the kind of the same jobs appear. And if we flip back to this, now you can see the ephemeral container that GitLab has spun up, which is actually running the jobs. It runs the jobs, it gets done, and then now it's running, so the next stage, the setup workspace, is these containers are running these two jobs, and now we're kind of getting into the get credentials stage, which is the next stage. So while that goes through, let me kind of talk about Vault a little bit, and we are getting toward the end of the demo, so we'll begin the discussion Q&A really pretty soon. I have an open source Vault server running. We have a ton of guides out there on how to start a Vault server. It is really easy to get started, so I'm not going to cover that in this demo. Once you have a Vault server up and running, what I have done is set up a GCP secrets engine. So a GCP secrets engine will generate Google credentials, Google service account credentials with limited timelines, with limited time to live. Right? So this is what we call dynamic secrets. So if you look at the configuration of that, you'll see that this secrets engine is configured to provide dynamically generated Google credentials that are valid for 300 seconds or 5 minutes. And we can actually go ahead and audit that as well. So if you're going to access leases, every time we issue a dynamic secret, it's wrapped under what's called a lease. So you can go and look at that lease, and you'll notice that this credentials that was issued to GitLab will expire in 4 minutes, right? So why would we even care about that? So basically, right, in an environment where you're following sort of best practices when it comes to security, right? Sort of least privileged access. You should also have sort of temporary credentials. So also kind of there's also separation of concerns. So a developer or person that's writing Terraform code or has access to this repository shouldn't necessarily have access to production Google Cloud accounts, right? So for all of those reasons, the dynamic secrets and kind of coupling that with a GitLab CI system is really powerful. Because GitLab is, in this case, my runners are in GKE or a Kubernetes system, you can also use a Kubernetes authentication method to have the runners authenticate to Vault and retrieve a secret. So again, that's an exercise left up to the reader, but the Kubernetes authentication method works really well for cases like this, where you have the runners executing in OpenShift or in any flavor of Kubernetes. All right, so that's sort of the Sentinel and the Vault pieces. Let's go back to kind of our apply stage, and if you look at the output, you'll notice that it has created that run in Terraform Cloud. It actually gives you a URL where you can go and kind of check out, what that run was. So if we kind of go back to the workspaces view, what you'll notice now is there is a additional stage here, right? So before we just saw plan and apply. Because we uploaded the Sentinel policy, we actually generated a policy failure. So what is the policy, right? So within the policy file itself, we have some print statements, so it's easy for you to understand kind of why there was a violation. So it says this policy uses Sentinel TF plan import to require that all Google Compute instances must have the machine types from an allowed list. So essentially, the machine that we were creating has a machine type which is N1 standard 2 that is not allowed, that is not in the allowed list. So we created a whitelist array of machines that you're allowed to provision, And because we kind of went beyond the whitelist, it flagged that as a policy violation. I'm going to go ahead and override and say that this is approved and allow the sort of the plan and the apply to continue, and go ahead and allow the server to get created within Terraform Cloud. This type of policy could be, like I mentioned before, it could be a cost control measure. Sentinel policy as code language is quite flexible, and we have a ton of examples out there of things you can do. Common things might include making sure that you have the right labels or tags applied, or making sure that you're already only provisioning from a whitelist set of security hardened images. So once the apply has finished, we can actually kind of hit this URL and see the application in action. That application gets installed via a startup script, so it does take like a minute or so to kind of come up. So we'll wait for this application to get provisioned. I just want to show you one more thing real quick before we get into Q&A. If you look at the apply, right, you saw this run ID. Now, based on the run status, there's also run status of pending, you can actually take a lot of different flexible actions. For example, you may send a Slack notification or some kind of a webhook notification. You may interact with an internal CMDB system. You may interact with ServiceNow, right? That's why the API-driven run is so powerful, is because you can create these flexible workflows. The pipeline code for this demo is kept really simple. So all it does is just print out the run result and the run status. But if you want to see an example of how you can act on those conditions, we have this Terraform automation script that, example where, and we'll post this as well, but you can see that, this is just simple kind of, bash scripting, which said, based on the run status, you can take different actions, right? So if there was a policy violation, maybe it creates a ServiceNow ticket, and maybe someone with the appropriate authority needs to go review that ticket and approve it, or just discard that run or cancel that run. All right, so finally, let's go and see if the application looks like it has been provisioned. So it's just a simple Go application. It just logs visits to a web page. So that really brings us to the end of the webinar. In conclusion, we have seen how to use GitLab CI/CD to interact with Terraform Cloud using the API-driven run. As part of the process, we've seen how to get temporary credentials from Vault and how to apply a Sentinel policy in the context of a run. And if you're doing this on your own, go to the blog post, and all of the steps are outlined there. This is the blog post that's associated with this webinar. And then finally, don't forget to destroy the server that you created. So we have included a destroy script as well. So you can just kind of set the right variables and execute this, and that'll queue a destroy plan within Terraform Cloud. So that brings us to the end of the demo section. So Brianna, I'll send it back to you.
Thank you both. That was great. So now we'll begin the Q&A portion of it. So if you have any questions, please just submit them through the GoToWebinar portal, and we'll get going. So first question we have is for Kausar. So can you expand on strategies for branching infrastructure as code, in particular, hitting different targets depending on branch?
Sure. I think there's quite a lot to unpack there. So, maybe I can probably give a high-level answer, and happy to kind of follow up on that. But we do have some best practices around how you should lay out your repository, and whether you should be using branching or directories or separate repos. So kind of stepping back a little bit, but they're kind of broad strategies, right? So you can have, what we recommend is to have a repository per application or per project. Some people will have a mono repo and have all of their Terraform code there, and they have different directories that correspond to different projects. Other people will also use branching as a strategy, where you can have sort of different variations of Terraform code, but they're similar within a branch, or sometimes the branches are used as a means to perform testing and promote your Terraform code from lower environments to higher environment. So with the GitLab CI, right, in the CI YAML spec, there are specific flags you can set where you can say, this job or this stage should be run only in a test environment, right? Or this entire pipeline should be executed if the commit or the merge happens in the dev branch. So I believe all of that flexibility is there. I'd have to allude to Kelly for more details around that. But at a high level, right, that's really where you'd implement that type of intelligence.
Yeah, just to add to that, that's awesome. That's a great answer, Kausar. But with regards to understanding more about the CI or the different variables and different things that can be set within GitLab CI and CD, it just Google GitLab space CI space YAML, and it's going to one of the top 3 results is going to be basically all the different commands that could be used in the CI YAML file itself that's in the root directory.
If I can just add one more thing, I do encourage you to just Google also Terraform infrastructure as code repository best practices, and we do have some documentation there as well. So that's all.
Perfect. Okay, so next question was, people were asking, what's the repo URL that you're using for the demo?
Yep, that's the easy one. So it's actually shown here. So it's just Kausar K, GitLab CI, Terraform Cloud demo. I would encourage you to maybe fork the repo, because if you don't want to use Vault, you may just comment out the get credentials stage, for example. So it just gives you more flexibility. Also, you're probably gonna want to have different ways to trigger the pipeline. So if you have a fork version, then when you kind of do a commit to your old fork, it'll trigger the pipeline. But yeah, to answer your question, it's just this URL up here, and we'll post it in the blog page as well.
Okay, perfect. The next one is, why does your pipeline start with a create workspace? Why not reuse existing prod/stage 1?
Yeah, that's a great question. So, so in this case, this is actually a bit of a misnomer. What I should this should probably be labeled as create or get existing workspace. So what it does is, if the workspace already exists, when it tries to create it, it'll just fail. And then, it'll just then echo out that, hey, there's already an existing workspace in this name, and here's the workspace ID. So this is not a mandatory step. A pattern that I have seen in other organizations, and I was pleasantly surprised to find that quite a few large organizations are using GitLab CI. One of the patterns is that they'll have a sort of a separate pipeline that just creates Terraform workspaces and then sets up credentials. Like they may set up AWS credentials or Google credentials from beforehand and set those as sensitive or write only. So in those cases, the workspace will already exist from before, and this this stage will not do much. It'll just kind of see, hey, does the workspace exist? If it exists already, it'll just echo out the workspace ID and exit, but it won't really impact the pipeline. One other thing I'll highlight is I do have a before script, which is really important. So regardless of whether the workspace exists from before or you created one, you do need the before script to get the workspace ID before every stage so that you can perform operations on that workspace.
Yeah, and just to add, with regards to on that before script, you could also use potentially an artifact. So basically, you could upload that directory that has the artifacts in them, and then carry those artifacts throughout. So in the example, and Kelsey already mentioned that the links will be posted, but in the project that I had where it basically deploys to AWS, I'm basically taking that Terraform directory and basically uploading that as an artifact and reuse in other stages. So there's different ways you can kind of slice and dice it depending on what you want to do. But the before script is definitely there. After script is another option, another, I guess in a similar vein, what happens after a job runs. So this is what happens before a job runs within a stage. So there's definitely a lot of options associated with how to set up and ensure that you have a consistent environment throughout the whole pipeline itself.
Perfect. Okay, so Another one, how do you manage AWS multi-account deployments in terms of the provider in an AWS organization context using only one TFC workspace?
Okay, so I would have to step back a little bit. I think that we may want to separate it out into multiple TFC workspaces, because really the workspace construct manages individual units of infrastructure. When you're managing a lot of infrastructure within a single workspace, you kind of increase your risk because you end up with a large state file. And whenever you do any plans or applies, kind of that entire state file is affected. So, the pattern that we encourage is to have more, just like you have microservices where you have a more smaller infrastructure units that you're managing in different workspaces. So if you're trying to manage the multiple AWS accounts within a single workspace, my first, word would be, maybe we should look at whether that even makes sense, to manage all of that within a single workspace. But if you really need to do it, I believe you can set up different providers within Terraform. So there's just a sort of a AWS provider block. If you, Google Terraform AWS provider, you can define that multiple times, and then each provider you can give it an alias. So you can say, right, this provider is the default one, but then this next provider is the dev one. This next provider might be in a different geography, for example. And then you can feed the providers with different AWS credentials. So in this case, you'd have to set up different Terraform variables or environment variables and get the, kind of supply the providers with the appropriate credentials. And then from that point, when you have your Terraform resources or modules, you can tell it to create this resource, like to create this set of VPCs or subnets, use the dev provider as an example. So I would say that's kind of the high-level answer to how you would go about it. Let me just kind of round it off by saying the only place I have seen that type of a pattern is if I'm trying to manage, I'm trying to mirror two environments. So sometimes I've seen people will create an entire environment in US East, and then they'll create an entire a mirror image of that environment in US Central, as an example, just using different modules, and then they'll have a provider for US East and a separate provider for US Central, and do it that way.
Okay, perfect. So the next question is, does the destroy.sh script delete all resources created in the last run ID?
It does, but in my blog post, I really encourage you to go make sure that it has been done. So what it does is it queues a destroy run. So let me go back here. So you can see it says destroy workspace using API. It'll remove the Sentinel policy. So if your subscription allows Sentinel and you have uploaded Sentinel, then it will delete the Sentinel policy. And then it'll queue a destroy run, and then it'll wait 2 minutes for the plan to complete. And then it'll go ahead and confirm that applies. So at the end, you should see something like this, right? Resources 0 added, 0 changed, 3 destroyed. You can also verify that using the state file. So if you look at the latest state in this workspace, basically everything should be X'd out, right? So Terraform Enterprise will kind of show what the latest state is up here, and you'll see that there's actually no real resources here. This instances array will be empty. So the answer is yes, it will attempt to destroy everything that you have provisioned, but please go back and make sure that it has indeed been destroyed through the UI.
Thank you. So I believe this one is for Kelly, but does triggering the run and apply using GitLab CI mean that I won't have to set up VCS connectivity on Terraform Cloud? And is it possible to create the workspace with variables in it using GitLab?
Yeah, absolutely. So I think, Kelsar, yeah, there we go. Perfect. Thank you. So he's reading my mind already. So within the CI/CD section itself, there's a variables section. You can see that there's different values that can be added. With respect to the variables themselves, you'll notice also on the, was that 1, 2, 3, 4, 5th column over, there's a masked there's a masked option. It would say that anything that is sensitive or things that you don't want to put out into logs, you would want to mask it. So, like for example, what I'm doing with my AWS focused Terraform pipeline with GitLab is I'm actually providing AWS credentials within the variables here. I'm actually grabbing those from a Vault server that I have. I use one of the Terraform Quick Start spin-ups where it spins up a bastion and then three Vault nodes and 3 console nodes up in AWS. I'm in that bastion host to get my credentials. I'm sending mine for 36 hours, which is a lot, but the reason I'm doing that is because I don't want to have to go back while I'm going through different runs and going through my development process. So one of the things that we are working on at GitLab is to integrate Vault directly into GitLab as well, so that those variables for Vault or credentials for AWS, for example, would not be exposed. And as an example, Kelsar has a way or a workaround to ensure that the credentials themselves are not actually listed in the variables within this project itself. So yes, absolutely. Whatever you want to put in there is going to basically be dumped into an environment. So one of the environment being on the GitLab Runner. GitLab Runner, as Kelsar mentioned earlier, can be anywhere. It could be a Kubernetes cluster. It could be on your laptop. It could be an instance somewhere. But to be cognizant of the fact that you are running commands on this external runner, you just want to make sure that you're not leaking information that could be used for Bitcoin miners or anyone else. Does that answer the question, or was there a follow-up?
Nope, that was it.
Perfect.
And then another one. So we got a couple more. So can we expect to see a Vault GitLab auth method anytime soon? Yeah,
I believe it's 12.7. Just to kind of give an idea of how GitLab works from a release perspective, we're currently on 12.4. Memory serves correctly. Every 22nd of the month, we release a new version, and 12.7 is 3 months away. So that's what, December, January? Yeah. So that's where we would actually be able to inject Vault secrets into GitLab. There's some issues there. I can actually link those. I think they may have been in the initial blog entry that we had between Hashi and GitLab, but either way, I'll make sure that that's in the resources as well.
Okay, I believe this one's for Kelsar. So is it possible for a Sentinel policy to load a whitelist from an external data source?
Good question. Very soon we'll be able to do that. So we are slated to kind of release this what's called an HTTP import, where you can make REST API calls, where you can kind of interact with external systems. So this has actually been a common ask, especially with some of the large financials that I've worked with, where they wanted to reach out to kind of AWS APIs to do some more intelligence, to apply more intelligence in policies. So the answer is yes, you can certainly do it very quickly using the HTTP import. It's going to be in an upcoming release. I don't know exactly which release, but it is coming soon. A workaround, like a pseudo workaround, is to use an HTTP data source. So as part of your Terraform plan, you can have a data source, and the HTTP data source can kind of reach out to an external system and load some data during the plan phase, and then during the Sentinel policy check, you can examine and act on the data as well. So that's a little bit of a workaround right now, but we'll have a kind of a better, kind of more direct way to do it coming up.
Great, thanks. So another one. Is there any guidance on how to pull configs and secrets from an on-premise vault into Terraform Cloud?
So from an on-premise vault to Terraform Cloud, okay. The challenge there is going to be network connectivity more than anything. So when you start up a Vault server, it exposes a REST API, and by default it runs on port 8200. Well, this one I'm running on Kubernetes, so I'm just using a node port. But the REST API endpoint is exposed on port 8200. Terraform Cloud is a SaaS offering, and we run it on sort of ephemeral infrastructure. I believe it runs on AWS, but we may run it on other infrastructure providers as well. The challenge is that there's no static IP necessarily. So if you're using the SaaS version, it's going to be difficult for you to have sort of firewall rules, because Terraform Cloud is going to running the plan and apply, and you're going to it's going to need to reach back into Vault to retrieve the credentials. So managing that firewall rule is going to be challenging. So a private Terraform Enterprise or Terraform Enterprise server on-prem might be a better fit. Now that's if Terraform itself is reaching and grabbing credentials from Vault. So we have the Vault provider that can do that. Alternatively, if you're using like a CI system, then you can have a runner, right, that's running on-prem, because like Kelly mentioned, the runners can be anywhere. So you can easily have a GitLab runner that's running on-prem, right? It's a trusted subnet within your internal network that can interact with Vault, get the credentials from Vault, and then set that as a variable in your Terraform workspace, right? And that way, you don't need to like worry about kind of coming back from cloud into on-prem. So if you can use GitLab runners, it gives you that flexibility. But otherwise, the answer might be a private Terraform Enterprise server.
All right, next one. Can Terraform Cloud notify GitLab at the end of a run to update badge status?
I will attempt to answer the question, and Kelly, just feel free to add anything. We do support webhooks within Terraform Cloud. So if I go into any workspace, for example, I'll just go into this one here under settings, right? And this can be done via API as well. I can create a notification. It could be a generic webhook, or it could be a Slack message. I actually have a Slack channel set up where I can get notified of all the runs, but it could be a generic webhook as well, where you can send basically a REST notification. So if GitLab has like some kind of incoming webhook system, we can certainly hook into that. I personally haven't tested it though.
Yeah, let me make sure. Okay, yeah, just want to make sure I was unmuted. Yes, so we definitely support webhooks. The one thing I would kind of throw out there as well is that within that job itself, if it exits out as a 0, basically no problems, then basically the job is confirmed as being complete. So if there were a way to basically link back and say like exit code 1, for example, or whatnot within that job, then that would be another way that it could work. It sounds like a great idea to further the integration that we're talking about here.
Yep, I totally agree.
Awesome. So another one, why would I want to use Vault over AWS Perimeter Store? What are the advantages?
Sure. I think that if Vault, I think Vault has a secret store. That might be what the person meant, or I'm not familiar with Perimeter Store specifically, but if that works for you in an AWS environment, we do encourage you to use it. But there's nothing wrong with using the sort of native capabilities that the platform provides. Vault is really designed to be a little bit more agnostic. So the idea is, as we kind of go on this journey, it's one of the slides I had, as we started the webinar, people are starting to look at sort of multi-cloud more and more. So chances are, even though you might be in AWS, this year, you're probably going to look at GCP next year, right, or the year after. You're probably already looking at Azure as well, because the platforms are always going to be good at very specific things. And Vault is really designed to kind of be very agnostic. So you can run Vault on-prem, on any of the cloud infrastructure. The clusters can be joined with performance replication. So all of the secrets and all of this configuration can be replicated as well. So I would say that's one advantage. As soon as you deploy kind of some workloads into a different cloud, now you have to deal with the complexity of what's my secret solution for that cloud, right? And GCP or Azure also has their own kind of secrets product. Now you're having to manage like AWS Secrets Manager and the Azure version of that as well. So I would say from a philosophical perspective, it's a little bit more agnostic. But again, if AWS is kind of solving a challenge in a good way for your team, that's completely fine as well. We love all the tools, basically.
All right, so we got about 10 more. The questions were rolling in. So when getting the temporary GCP credentials from Vault, is it possible to mask their contents so they are not printed in the CI logs.
Right. So I have to test that a little bit. I know there's some restrictions with what you can mask. Like, there are some patterns. The Google service account is especially challenging just because the Google service account is not just a simple string. It's actually a pretty big JSON file. It's got like all these keys, all this metadata. So it's this like big JSON string that you have to kind of get from Vault, and then you have to base 64 decode it, and then you have to set that as an environment variable within Terraform Enterprise, which is kind of what was, well, this is a different workspace, but it's the same idea. So essentially, we set it as write only, so it cannot be shown here. So I don't know the answer to masking it. What you could do is you could apply a Sentinel policy that says that no one can do funny things like put in a local exec that prints out the credentials, right? Like, so that would be something that Sentinel violates, like as a policy. I think we have an example of kind of no local execs. So you can check on things like that. But I might have to take that as a follow-up. Kelly, if you could add anything here as well.
Yeah, I mean, I think that how we deal with that within GitLab itself, you're right. I mean, if you could dump the environment variables, you can do an env within the runner job, and it's going to throw out everything. But if you go to that project settings, Kelsar, and go to variables, or sorry, CI/CD variables. Yep. There we go. So that's why it's important to have that masked checkbox. With respect to how we will be integrating with Vault, my understanding is that it's going to be basically there's going to be a runner that's assigned to a project. So the whole idea is that the runner is in a controlled, secure environment. That's at least the initial go around for how we will integrate there. But I think that there's probably going to be different ways that you can integrate, and as you've shown there, you have a Vault token that then basically retrieves credentials. As you just mentioned with Google, with that JSON file that's spit out from IAM, it's a bit more challenging to deal with. Where with respect to AWS, it's just basically key and secret, and there you go. And it's good for however long Vault's policy set up to keep it alive or use it or multiple uses, right? Yeah.
Yeah.
All right, next one. Oh, go ahead, Kausar.
Sorry, I was just going to add just 10 more seconds to that. So thanks, Kelly, right, for that answer. I think that first-class integration would be really nice. Sometimes, customers will look at kind of more risk mitigation strategy that, hey, ultimately, like, what happens if I do leak credentials, right? And that's where really the dynamic secrets and time to live come in. So if you look at Vault, right, this credential has already expired. So if I click on this, like, it's actually not valid anymore. So sometimes you do get cases where you have different logging systems, applications which are just bad at keeping secrets will, right, print out a credential or a password. And then at that time, it's about kind of limiting the blast radius. So in this case, because the credential time to live was so short, it was only 5 minutes, that chances are that credential is not going to be any good anyway. I know that doesn't answer your question. It's just one of the risk mitigation strategies, right, in this topic. But yeah, so hopefully we'll see some better integration there where you can't kind of print out the credentials at all. You may also use some linting. So one of the, sorry, I know this like answer is taking long. This pipeline, for simplicity, like we haven't added any testing phase, but I think, Kelly, correct me if I'm wrong, but generally you'd have a stage that does some linting. So if somebody's doing some nefarious things like printing out credentials or something, or dumping out environment variables, then you may catch that as part of a stage as well. So that could be another risk mitigation strategy.
Yeah, so I think with respect to that, I mean, environment variables, I think it's very important to have it masked for that reason. With respect to if there's secrets that are within your code, on the enterprise version of GitLab, we do have a static analysis tool that will basically look for secrets, and we'll basically say, got a problem here. You need to basically take these secrets out of your repo. That being said, there are there are ephemeral credentials that will last for like 5 minutes to 15 minutes or whatever that are within a repo. By the time it gets to master, maybe it's already dead, right? So I think you're right in that you have to limit the exposure or the potential blast radius of putting secrets into any kind of code or having those secrets available with any kind of environments. The other thing that you could do potentially, Kelsar, is within Vault, you could also, I guess, you could limit the number of uses as well. So if you had somebody that was
absolutely
trying to pull up 500 instances on AWS to basically mine Bitcoin or Ethereum or whatever, then it would basically just fail because you just set it for 5 or 10 or whatever.
Yeah, absolutely. There's a lot of flexibility in the way you set up the secrets engine, the way you set up the policy. I actually have a policy that's set up for GitLab Runner. So you're not able to just get any credentials, right? The idea is you may have different policies for different environments, and then only the runner container is allowed to get to this policy. So if I'm just a rogue person, right, there's no way for me to even kind of get those credentials in the first place. But then, whatever credentials I get, there's limited capabilities around that. So you can limit the number of users. Obviously, you can limit the time to live associated with that as well. Some of that is in the Vault setup. So in the Vault setup script, you'll see kind of a set of commands. And one of the commands is kind of doing this binding, right? So maybe I can kind of pull that up real quick. So here we have this kind of binding, right, where we say when somebody
Kelsar, I think we lost your mic.
So I want to make sure it wasn't me. So, yeah. Let me see if I can read his lips.
There is one question for you, Kelly, so we can go ahead and do that, and then I think we'll close it out for time. So Kelly, can you replicate GitLab repos between TF organizations and TF workspaces?
I don't know the answer to that, honestly. So I think that's it really depends on if it's doing how TF Cloud is or if it's basically doing if it's basically doing a pull or a push or whatever. I'm not sure. I don't know, Kelsar, if you're back or not. I think your audio cut up.
Yep, my apologies.
You might be able to answer that because I don't know.
Okay, I'm sorry, I actually missed the first part of the question. I apologize.
No problem. So can you replicate GitLab repos between TF organizations and TF workspaces?
Replicate GitLab repositories between. So I guess I'll answer that with a caveat. We may have to dig into exactly what that means, but essentially, like in the workspace, in the list of workspaces that you saw, right? You've noticed that there's some of the workspaces have a direct relationship with the repository. If the question is like, can you replicate these workspaces, right? The answer is yes. So we have a Terraform enterprise provider, which you can use to manage all of these repositories as code. So you can certainly write some Terraform code that'll create a workspace, right, and link it to the same repository as some other workspace. But we actually had like one of the solution engineers, and maybe we can post that as well, but one of the solution engineers wrote up this like nice little web app where you can input some parameters, click on apply, and it's almost like a workspace vending machine, and you just get a new workspace, and you can sort of copy one workspace to another workspace, etc. So again, if the question was like whether you can duplicate workspaces and maintain the repository relationship, then the answer is yes, but I'm not sure. We may have to dig into that question more.
Okay, perfect. And then everyone else who answered questions, we don't have time on this webinar, but we will get to them. So thank you for your expertise, Kelsar and Kelly. As I mentioned at the beginning, this Hangout was recorded, and the recording will be available on our website after processing. And I will also send an email out to everyone who registered with the recording link. And if you would what you heard today and want to start exploring Terraform and Vault, I encourage you to check out our new Learn sites. So you can find it on our website, learn.hashicorp.com. And I hope you enjoyed today's hangout and have a better understanding of how to implement a Terraform Cloud API driven run in GitLab CI/CD. Thanks for hanging out with us today, and a big thank you to Kausar and Kelly for their time. So that wraps everything up. Have a great day, everyone.
Thank you.
Thanks all.